good morning. Those of you joining us in person and out there. Yeah, so let's graph this one without the use of a calculator, and then let's state the asymptotal and behavior. So I would do all of your work on a piece of one of those pink graph papers because there's plenty of room for you to do your work on that. Okay, go for it. Agree? Domain, all real numbers, x can't be 0. Gives me a vertical asymptote at x equals 0. Okay? Again, if you wanted to put yours on your line with a, instead of, it's got to be a dashed line, but if you wanted to use slashes for it because it's coming right down the vertical axis, that's totally up to you. Degree of the top for my horizontal asymptote is 1. Degree of the bottom is 1. So that's going to be the same case. So then I take my lead coefficients. So my horizontal asymptote would be y equals 2 over 1, or just 2. Agree? Next up is my y-intercept. I know that I can't have a y-intercept without even calculating it, okay? Because I got a vertical asymptote as the y-axis, okay? So we're not going to have one. But if I didn't see that, I would find g of 0 here. So that would be 2 times 0 minus 1 all over 0, which is negative 1 divided by 0, which can't happen. So my y-intercept, there is none. X-intercept next. I take my numerator, 2x minus 1, and I set it equal to 0. Solve it. So I'm going to add 1. 2x equals 1. X equals 1/2 when I divide by 2. So my x-intercept is going to be the point 1/2, comma 0. So that's that. Step 5 we don't have yet. Step 6 we don't have yet. So next up we've got step 7, which is, let's pick some points. Let's go with negative 1. If I put in negative 1, that's going to give me negative 2 minus 1 is negative 3 over negative 1. That's positive 3. 10. That would be negative 21 all over negative 10, which is positive 2.1. There. Let's do 1 and 10. 2 times 1 is 1, minus 1 is 1. 1 is 1. 10 times 2 is 20, minus 1 is 17, minus 10. I get this. Agree? Love it. Then it asked us to do end and asymptotal behavior at the same time, or at the very end, because it's easier to get it off of the graph. So let's do end first. x is approaching 2 from below. Not negative 2 there. I saw that a couple of times in last week's homework. Okay? It's not approaching negative 2. It's approaching 2 from below. As x is approaching negative infinity, my function g of x is approaching 2 from above. Asymptotal behavior as x is approaching 0 from the left, my function is going to positive infinity, and as x is approaching 0 from the right, my function is going to negative infinity. Agree? And again, that's much easier to get right off. Okay. Good. Next. So, what happens if my numerator and my denominator have common factors? What I mean by that is, what if we ended up with something like 6/8? Do I like the fraction 6/8? No, because they both can be reduced by 2, right? So what I mean by a common factor here is like 6 is 2 times 3, and 8 is 2 times 4. And these 2's are the common factors. And we factor them out, and we're just left with 3/4. Okay. In a polynomial type function, we could have something like x minus 3 on top, and x minus 3 and x plus 2 on the bottom. Okay? Then in that case, the x minus 3's would cancel each other out, and we would just be left with 1 over x plus 2. We've done that before. Simplified. Or we might have something that looks like x squared plus 3x minus 10 and x squared minus 25. Okay, polynomial over polynomial. Well, the top is x plus 5 and x minus 2. The bottom is x minus 5 and x plus 5. And then the x plus 5 cancel out, leaving me just with x minus 2 and x minus 5. Common factors. Okay. Just so you know, as a side note, because I've seen it happen 1,000 times, 3x plus 5 divided by x. You cannot, don't just drop the x's. Okay? You can't just cross off the x's here. Okay? That's bad math. Okay? Can't just whack off the x's because there's one on top and one on the bottom. Just like up here in this one, we couldn't just cross off the x squareds. Okay, we have to factor. The only way we can get common factors is by factoring. Okay? So let's go to our sheets, our extra sheets, our cheat sheet. Okay? Step 0 now is what we're going to do very first, right off the start, okay, is we're going to simplify. Step 0, so it should go right up at the top. Yep. If you got one line up there, that's all you need. Because it's literally, step 0 is simplify. Okay? We're going to do that first. Okay? We're going to simplify first. So we're going to factor the top and the bottom. If the same term is being used, we're going to cross it off. We're going to simplify it. And we're going to make our polynomial function even easier. So that's step 0. But because we've done step 0, now we've got to do step number 5. Okay? Step number 5 then is if we did factor something out in step 0, that creates a hole in our graph. Okay? So if we factored something out in step 0, we're going to set what we factored out equal to 0 and solve that. That's going to give us an x value, the x part of our hole. We're going to take that value and we're going to plug it into our brand new function. Not our old function, because we're going to get a denominator of 0. We're going to plug it into our new function, and that's going to give us the corresponding y value for our hole. Okay? So on the graph, we literally put a hole in that position. Okay? Okay? So, I did get the good graph. What is that? Oops, let me make sure that you guys got enough time to write that down. Okay, everybody got that written down? Okay. If you're joining us not live, but on the video, you can always pause it and write that down and then continue on with it. Okay? All right, here we go. All right, so here we go. So step 0 says we've got to factor. Okay? So if I factor this function, I get x minus 2 on the top, and the bottom factors to be x minus 2, x plus 2. The x minus 2's cancel each other out. That leaves me with the function of 1 over x plus 2. With me? Okay. I go back to, so we're going to kind of jump around a little bit here. Okay? Step number 1, so that was step number 0. We factored it. Step number 1 now says we have to find the domain in any and all vertical asymptotes. Okay? So the domain, I look back to here for the domain. It's my original function. So I would say x squared minus 4 equals 0. So x squared equals 4. So x equals plus or minus 2. So the domain of this function is all real numbers, but x cannot be plus or minus 2. With me? Okay. From now on, from this point forward, now I use that function as my function for everything else. Okay? Domain is the only one where I go back to my original function. From that point forward, I use everything off of my new function. So my vertical asymptote here is going to just be x equals -2. And that's it. Because at +2, I'm going to have a hole. Okay. My horizontal asymptote, I got 0 on the top, I got 1 on the bottom. That's a small over big, and so that's going to be y equals 0. Put those on there. What did I say? -2. And use our hole. My y-intercept I'm going to find f of 0. So that's going to be 1 over 0 plus 2, which is 1/2. So my y-intercept is at 0, 1/2. My x-intercept, I set the numerator 1 equal to 0. Can 1 ever be equal to 0? Nope. Okay. So there is no x-intercept. Okay. I factored something out. So because I did that, I am going to have a hole. Okay. What I factored out was x minus 2. So I take x minus 2, I set it equal to 0, and I solve it. And I get x equals 2. So my hole is going to be at 2, comma, something. Okay? I take that 2 and I plug it into f. So I'm going to find f of 2. So that's going to be 1 over 2 plus 2. That's going to be 1/4. Agree. Okay? So my hole is at 2, comma, 1/4. And I literally go to my graph. Come on now, scroll up for me. I literally go to my graph, and at 2, comma, 1/4, I put a hole. I don't fill that hole in. I leave it a big open dot. Okay? Then we can come up with extra points. So let's start with -3. That would be 1 over -1. So that's going to be -1. And -10 is going to be 1 over -8. So we get that. On the other side, we can do -1. That's going to be 1 over 1, which is 1. And 10 is 1 over 12. Okay? Now, here is how we draw our graph down. On the non-whole side, we just draw it normal. Okay? On the whole side, I draw it like it's normal, but I stop when I get to my hole. I pick up my pencil and I start on the other side. Don't fill in your hole. Okay? Because your hole is literally that. It's a hole in your graph.
Would it be okay if you just like punch a hole in the page?
That'd be hard to do on the computer though.
Yeah.
You know what I mean? So yeah, so don't just punch a hole in the page, just draw your hole. Okay? And that's it.
Can you go back to the little chart that we
You down here?
Yeah. Oh.
Yep. And then again, same thing. I plug those into my new function.
Where do you get those numbers?
I always go the whole number right next to a vertical asymptote on either side. So in that case, it's -3 and -1. Okay? And then I go far out. So I go to the end. So I go -10 and positive. Okay? Ready to try one on your own? Let's do this, man. And then go to the next page. There we go. Okay? Sketch the graph, include any intercepts, asymptotes, and holes. So that's what we've been doing. Yep.
Hey, are we not doing like the end behavior and asymptote?
It didn't ask us to do it on that one. Directions are key because sometimes we'll do them and sometimes we won't do them. Just so we're all on the same pace. Top stays x plus 6. Bottom factors to be x plus 6 and x minus 1. So my simplified function would be 1 over x minus 1. So for the domain then, we go back to the original function. I got all real numbers, but x cannot be -6 or +1. Right? But for my vertical asymptotes, I go to my new function, and it's just x equals 1. Because at -6, there's going to be a hole.
You show how to
I'll say,
solve
how did you, because
the x squared plus 5x minus 6 equals 0.
Two numbers that multiplied together to be -6 and add to be +5. 1 and 6 multiplied together to be +6.
-1 and 6.
Yep, so it's -1 and 6.
Okay, for the one that we did before,
Mhm.
we're going to find the domain with all your numbers that actually doesn't equal to positive or -2. And like we saw, we made the denominator equal to 0, right?
Yep.
And we do the same thing for this one, right?
Yep,
So when you got, for the one with the top now on,
Yep.
where x is not equal to -6 over,
yep. Because I take the factors, because if I factor it,
I thought we were using the original to find out.
we are, but this is still the original one. So what you're saying here is you would start, so we set the denominator equal to 0. Right? Right? Okay? Then how are you going to solve that? Factor it, right?
Oh, I get it.
Okay? Right? Okay? So what I did, the only thing that I did is I skipped that step. And because I factored it already, so I just put my factored form equal to 0. Okay? And then I said, so then here I said that x plus 6 equals 0, so that's where I got my -6. And x minus 1 equals 0, so x equals positive. Okay? With me? What's up, Tosh? Oh, okay.
Yeah.
So we're farther along than that.
Yeah.
Okay. Arch?
Could you re-explain how to do that factoring thing, like the exact same way you did it before? Cause
Okay. So when there's no coefficient here, right? When that's just a 1, so it's the two numbers have to multiply to be that one, and they have to add to be that one.
Okay. So I've had it switched around for the past year.
You want add and multiply?
Yeah.
Yep. Multiplies the far one, adds the middle one. Okay. All right. So then my horizontal asymptote is y equals 0, because I've got a 0 on the top, 1 on the bottom. So that's going to be y equals 0 is my horizontal asymptote. Put those on there. Vertical is at 1. Horizontal is at 0. Okay. Y-intercept. So f of 0 is going to be 1 over 0 minus 1. It's 1 over negative 1, which is just negative 1. X-intercept, numerator is 1. Set that equal to 0, and that is not possible. So my x-intercept is, oops, the point there, is none. One, two, three, four, 5 is find the whole. So we factored out x plus 6. So I'm going to set that equal to 0, and that's going to give me negative 6. And then I have to put that into my function. 1 over negative 6 minus 1. That's going to be 1 over negative 7. So my whole is at negative 6, comma, negative 1, 7. Better say. What's up? Right. That's why it's a hole. It's a point of discontinuity. 6. There's my hole. Draw it in. Two, 1, 10. And this one just asked us to do that, didn't ask us to. Yes? Love it. Let's do one more. Go for it. And cancel out. Nope, so what does that mean?
No.
No hole. That's the only thing that means. Everything else is the same. Just don't have a hole on this one, because nothing cancels out. Okay? So we can go and we can say the domain is all real numbers, but x cannot be plus or minus 2. Sure. There we go. My vertical asymptotes would be at x equals negative 2 and x equals positive 2. Okay. Not everyone's going to have a hole. Okay. Degree on the top is 2. The degree on the bottom is 2. So that's the same. So my horizontal asymptote then is going to be y equals 2, because the lead coefficient on the top is 2, the bottom is 1. So put those on.
The two.
Okay. Y-intercept. Two times 0 minus 9 all over 0 minus 4. So that's negative 18 over negative 4, which is 9x. 9/2 is 4.5. Right there. X-intercept. Set the numerator. I already got it in factor form, so I might as well use it in factor form. Equal to 0. Then x minus 3 is going to be 0. X 3. X plus 3 is going to be 0. So that's going to be negative. So I have two x-intercepts at 3 comma 0 and at negative 3 comma 0. Can 2 equal 0? I mean, I could distribute it into one of them, but then I'm just going to divide it at the end.
Like in the middle one, you have to find points if you draw the.
We got to find the points because we don't know if it's going to be going like, like the disco guy or if it's going to be a touchdown.
Okay.
Okay? Alright? So let's find some points here then. So let's go up here. So we already got that, so then let's go negative 10. 100 minus 9 is 91, times 2 is 182. 100 minus 4 is 96. Good catch. I'm thinking that is less than 2. 1 point like 9-ish.
I'll trust you.
Yeah? I'm hoping so. We're going to go with it anyway. Let's do the other zone right away, too. What? What do you got? 1.8. Oh, that's off by 0.1. Oh, I feel so bad. Because the positive 10 is going to be the exact same thing. Because we're squaring all of our variables. Okay. So then that just leaves me this middle section of negative 1 and positive 1. 1 minus 9 is negative 8. 2 times negative 8 is negative 16. 1 minus 4 is negative 3. So that's going to be positive 5 and 1/3. Draw it in. Don't have to worry about holes. That's a good thing. Well, there we go. Yeah, buddy? Awesome sauce. So, you should be able to do up to number 3 now on this week's worksheet. If you haven't turned in last week's worksheet or taken last week's formative assessment yet, you are behind. Don't be behind, be ahead.